You've never been to heaven, have you?
Assalamualaikum warahmatullahi wabarakatuh. Hi there.
Hello everyone.
Hello everyone!
Back again with Heaven Group. So in this video, we are going to explain about the maximum and minimum of a function. But before we begin, let us start with introducing ourselves. My name is Andi, Putri, Ahira.
My name is Dayang, Anisa, Safitri.
My name is Audriana, Septiani.
My name is Denzel Sudjono from Heaven Group.
From Heaven Group,
I'm from Heaven Group,
From Heaven Group.
from International Management Class, Faculty of Economics and Business Untan.
in this video, I'm in charge of explaining functions with two variables.
I want to explain about the first derivative and second derivative in the maximum and minimum values of a function.
In this time, I want to explain how to solve the maximum and minimum value of a function question.
And I'm in charge to explain practice question number 4, 5, and 6.
The maximum and minimum of a function are also called extreme points or extreme values of the function. The two terms maximum and minimum are the largest and smallest of the function, either within given range or the entire domain. How to find a maxima and minima using first derivative test. The first derivative test is used to determine whether a function is increasing or decreasing on its domain, and to identify its local maxima or minima. The first derivative test is considered as the slope of the tangent line to the graph at a given point. When the slope is positive, the graph is increasing, whereas when the slope is negative, the graph is decreasing. When the slope is zero, the point is considered as a critical point and it can be a local maximum or minimum. The second derivative test is useful when trying to find a relative maximum or minimum of a function has a first derivative that is zero at a certain point. Since the first derivative test fails at this point, the point is an inflection point. The second derivative test relies on the sign of the second derivative at that point. If it is positive, the point is a relative minimum. And if it is negative, the point is a relative maximum. So we're going to the examples. Find the maximum and minimum points of the following functions: 2x23 minus 3x22 minus 12x plus 5. Solution: we need to find the first derivative. Let fx equals 2x23 minus 3x22 minus 12x plus 5. Fx and x equals 2 multiplied 3x22 minus 3 multiplied 2x minus 12 multiplied 1 plus 0. So the first derivative is 6x22 minus 6x minus 12. The first step, we need to equating fx and x to 0. So 6x22 minus 6x minus 12 equals 0. And then divide both sides by 6. So x22 minus x minus 2 equals 0. And then we find the x by these patterns. So the x are 2 or minus 1. The third steps, find the second derivative. So the second derivative is 12x minus 6. The next steps, substitutes x equals 2 in second derivative. So the second derivative of x equals 2 is 18 greater 0, minimum. To find the minimum value, substitute x equals 2 in fx. Fx equals 2x23 minus 3x22 minus 12x plus 5. F2 equals 2 multiply 2 to 3 minus 3 multiply 2 to 2 minus 12 multiply 2 plus 5. So the result is minus 15. The last steps substitutes x equals minus 1 in second derivative. So the second derivative of x minus 1 is minus 18 greater 0 maximum. To find the maximum value, substitutes x equals minus 1 in fx. Fx equals 2x23 minus 3x22 minus 12x plus 5. F minus 1 equals 2 multiplied minus 1 to 3 minus 3 multiplied minus 1 to 2 minus 12 multiplied minus 1 plus 5. So the result is 12. Therefore, the maximum point are minus 1, 12 and minimum point are 2, 15.
So, our aim is to generalize these ideas to a function of two variables. Such function would be written as z equals to f of x, y, where x and y are independent variables and z is the dependent variables. The graph of such function is a surface in three-dimensional space where maximum point is portrayed as the top of the hill and minimum point portrayed as the base or the bottom of the hill. To make it easier for you to understand, you can look at this picture right over here. In the picture A, point A is the maximum point because the value of the function is bigger than any point surrounding it. That's why the maximum point is being portrayed as the top of the hill. The same goes for point B in picture B, which is minimum point, because the value of a function in that point is the smallest compared to the other points surrounded, which is why you can see it's being portrayed as the base or the bottom of the hill. A point of A, B, which is a maximum, minimum, or saddle point, is called critical point or stationary points. To find a critical point of f of x, y, work out partial f with respect to x and partial f with respect to y and set both to 0, which applies to the first rule of functions with two variables in this case. After that, we can classify the critical points of a function with two variables using the d-test or the second derivative test, which applies to the second rule of functions with two variables. So for the d-test, let d be the function defined by d of x, y equals to fxx of x, y, fyy of x, y minus 2fxy of x, y squared. If d of a, b is bigger than 0 and fxx of a, b is smaller than 0, then it's a maximum point at a, b. If d of a, b is bigger than 0 and fxx of a, b is also bigger than 0, then it's a relative minimum point at a, b. If d of a, b is smaller than 0, then f has a saddle point at a, b. And if a d of a, b is equal to 0, then it's no conclusion. Or you can see the other way of understanding classify of critical points using the second derivative test for functions of two variables. So, for example here, there is a function of f of x, y equals to 2 minus x squared minus xy minus y squared. So for this function, first we have to look for the partial derivative of the functions. So the partial derivative with respect to x is negative 2x minus y, and partial derivative with respect to y is equal to minus x or negative x minus 2y. After we find the partial derivatives of each x and y, we now have to find the second order partial derivative. So the second order partial derivative of fx is negative 2, and the second order partial derivative of fy is also negative 2, the second order partial derivative of fxy, which is negative 1. After we work out the partial derivatives, we now set both of them into 0. So for stationary points, or for the critical points, is negative 2x minus y equal to 0, and negative x minus 2y equal to 0. So the only possibility of x comma y is 0 comma 0. Now we have fxx fyy minus fxy squared. So equal to fxx, or the second order partial derivative of x, is negative 2. The fyy is also negative 2, so negative 2 times negative 2 minus 2fxy squared, which is negative 1 squared. And the result for it is 3. So this is basically the d of ab, which applies to the second rule and the d test. So the dab equals to 3, which is bigger than 0. So that 0 comma 0 is either max or a min. Since fxx, which is negative 2, is smaller than 0, and fyy, which is also negative 2, is also smaller than 0, then it is a maximum, which you can see based on the second rule here, the first of the d test, which is if d of ab is bigger than 0 and fxx of a comma b is smaller than 0, then it's a maximum point.
The first question is calculate the maximum and minimum value of a function fx equal to x power 2 minus 4x with the interval minus 2 smaller than equal to x smaller than equal to 4. To answer this question, first we need to find the derivative function of fx equal to x power 2 minus 4x. It is f prime x equal to 2x minus 4. After that, the stationary condition is f prime x equal to 0, and then 2x minus 4 equal to 0, and then the result is 2. So the stationary value is f open bracket 2 close bracket equal to 2 power 2 minus 4 times 2, and the result is minus 4. After find the stationary value, next we're gonna substitute the variable into the first function. From the interval, we can know that the variable is minus 2 and 4. F minus 2 equal to minus 2 power 2 minus 4 times minus 2. It is 4 plus 8, and the result is 12. If the variable is 4, here is the form. F4 equal to 4 power 2 minus 4 times 4. Now, we already get two numbers. Those are minus 4, 0, and 12. So, the maximum value is 12 and the minimum value is minus 4. Second question, define the maximum and minimum value of a function fx equal to 2x power 3 plus 3x power 2 minus 12x plus 7. To answer this question, first we need to find the derivative function of fx. It is f prime x equal to 6x power 2 plus 6x minus 12. Next, we want to find the stationary point with the formula f prime x equal to 0. So it is 6x power 2 plus 6x minus 12 equal to 0. From this factoring, we can get open bracket x plus 2 close bracket open bracket x minus 1 close bracket equal to 0. So the result is x equal to minus 2, x equal to 1. The next step, we need to substitute the variable into second derivative function. The second derivative function is 12x plus 6. Therefore, it is 12 times minus 2 plus 6. And the value is minus 18. If the value is smaller than 0, so it is the maximum value of a function. Next, we back to substitute the variable to the first function to find the maximum value. Fx equal to 2 times minus 2 power 3 plus 3 times minus 2 power 2 minus 12 times minus 2 plus 7, and the result is 27. So the maximum value of this question is 27. After find the maximum value, now we move to find the minimum value. The variable is 1, so x equal to 1. It is fx equal to 2 times 1 power 3 plus 3 times 1 power 2 minus 12 times 1 plus 7, and the result is 0. So for this question, the maximum value is 27 and the minimum value is 0. The third question, define the maximum and minimum value of fx equal x power 3 plus 3 x power 2 minus 9x plus 5 with the interval 0 smaller than equal to x smaller than equal to 3. To answer this question, first we need to find the first derivative function of x power 3 plus 3x power 2 minus 9x plus 5. It is 3x power 2 plus 6x minus 9. Next, we want to find the stationary point with the formula f prime x equal to 0. So it is 3x power 2 plus 6x minus 9 equal to 0. From this form, we find the factoring. It is open bracket x plus 3 close bracket open bracket x minus 1 equal to 0. So the result is x equal to minus 3 and x equal to 1. Next, we're gonna find the stationary value by substitute the stationary point into the function. For the x equal to 1, it is 1 power 3 plus 3 times 1 power 2 minus 9 times 1 plus 5, and the result is 0. After find the stationary value, now we want to multiply the variable that we get from the interval into the f function. Those are 0 and 3. For x equal to 0, it is 0 power 3 plus 3 times 0 power 2 minus 9 times 0 plus 5, and the result is 5. Next, for the variable is 3, the form is 3 power 3 plus 3 times 3 power 2 minus 9 times 3 plus 5, and the result is 32. So the maximum value is 32 and the minimum value is 0.
Number 4. If f(x) equals to x to the power of 3 minus 48x minus 9, find the maximum or minimum points. Fx equals to x to the power of 3 minus 48x minus 9. The first derivative of fx is equals to 3 times x to the power of 2 minus 48. At minima or maxima, the first derivative is equals to 0. So 3x to the power of 2 minus 48 equals to 0. Also equals to 3 times x minus 4 times x plus 4 equals to 0. So the solution to this equation is either x equals to 4 or negative 4. At the values of x less than 4, the value of the first derivative is negative. And at the value of x to the more than 4, the value of the first derivative is positive. So the first derivative of the function is increasing. So we have a minimum point where x equals to 4. The value of the function of 4 is negative 137. Hence, the minimum point is 4.137. And then to find the maximum point, at values of x less than -4, the value of the first derivative is positive. And at the values of x more than -4, the value of the first derivative is negative. The first derivative of the function is decreasing, so this is a maximum point where x equals to -4. The value of the function of -4 is 119. Hence, the maximum point will be -4, 119. Number 5. The question is if fx equals to -x to the power of 3 minus 6 times x to the power of 2 minus 1, find the maximum or minimum point. Fx equals to -x to the power of 3 minus 6x to the power of 2 minus 1. So the first derivative will be -3x to the power of 2 minus 12x. At minima or maxima, the first derivative is 0. So -3x to the power of 2 minus 12x equals to 0. Also means -3x times x plus 4 equals to 0. So the solution to this equation is either x equals to -4 or x equals to 0. At values of x less than -4, the value of the first derivative is negative. At the values of x more than -4, the value of the first derivative is positive. So the first derivative is increasing, so we have a minimum point where x equals to -4. The value of the function of -4 is -33. Hence, the minimum point will be -4, -33. At the values of x less than 0, the value of the function of the first derivative is positive. And at the values of x more than 0, the values of the first derivative is negative. So the first derivative is decreasing. So this is a maximum point where x equals to 0. The value of the function of 0 is -1. Hence, the maximum point will be 0.1. The last number, the question is if fx equals to x to the power of 3 minus 6x to the power of 2 minus 15x minus 5, find the maximum or minimum points. Fx equals to x to the power of 3 minus 6x to the power of 2 minus 15x minus 5. So the first derivative will be 3x to the power of 2 minus 12x minus 15. At minima or maxima, the first derivative is equals to 0. So 3x to the power of 2 minus 12x minus 15 also means 3 times x plus 1 times x minus 5. So the solution to this equation is either x equals to -1 or x equals to 5. At values of x less than -1, the value of the function of the first derivative is positive. And at the values of x more than -1, the value of the first derivative is negative. So the first derivative is decreasing, so we have a maximum point where x equals to -1. The value of the function of -1 is 3. Hence, the maximum point will be -1.3. At values of x less than 5, the values of the first derivative is negative. While at the values of x more than 5, the values of the first derivative is positive. So the first derivative is increasing, so this is a minimum point where x equals to 5. The value of the function of 5 is -105. Hence, the minimum point will be -105.